David, welcome to Talk Satellite here in Washington.
Thank you. It's a pleasure to talk with you.
Can you give us more detail on Applied Aerospace and Defense and your role with the company?
Sure. Applied Aerospace and Defense is a leading manufacturing company that serves three domains: space and launch, defense aviation, and C5 ISR and precision strike. And so the company does high quality precision manufacturing at scale. The breadth of the company is truly amazing. We serve everything from launch vehicles, satellite, aircraft, helicopters. So basically any space and defense system that you can think of, Applied provides components for. Since we're here at the Satellite 2026 conference, let me highlight some of the space and launch applications. With launch vehicles, kind of starting from the top down of a launch vehicle, we provide nose cones, payload fairings, payload adapters, propellant tanks, engine nozzles, and even landing legs for reusable launch systems. So it's truly amazing the breadth of the company. For satellites, we provide satellite spacecraft buses, deployable solar arrays. A couple of things I'll highlight. We provided the high-gain antenna for the Europa Clipper orbiter, which is en route to the Jupiter system right now. We also provided the sun shield for the James Webb Space Telescope, which was a 300 square meter deployable with 5 different layers that basically goes in between the optics of the telescope and the spacecraft. We always keep the sun on the far side of that shield. It keeps the optics cool so they can make those very precise thermal infrared measurements. So the breadth of the company is amazing, but the unifying theme for the company is precision manufacturing at scale. So we're really known for that precision manufacturing aspect.
Can you bring us up to speed how you became involved in the company?
Absolutely. So my position at Applied is the Vice President of Deployable Systems. I came on board Applied just a couple of months ago. A company that I founded, Vestigo Aerospace, was acquired by Applied. We kind of got on their radar because the company that was providing our sails and booms for this product we're going to talk about today, a drag sail, were manufactured by Nexolve, which is a company that Applied acquired almost exactly a year ago. And so we knew Nexolve very well, thought very highly of the organization, and we're just ecstatic to be working with this organization because Applied's focus on quality precision manufacturing is exactly what we need.
Deorbiting systems, why are they becoming so important?
Deorbit systems are gaining in relevance every day now. As most folks know, the number of spacecraft that are launched into orbit is just growing exponentially. Almost every day, there's a new satellite constellation that's announced. And people think of SpaceX and OneWeb as the big mega constellation companies. But every day in the news, there's another satellite constellation that's being developed for many applications. And in the Department of Defense, rather than having large multi-billion-dollar monolithic satellites, they want to disaggregate their systems so that they have smaller, more mobile, robust systems. And frankly, they're not a single big target. Just the number of satellites into orbit is growing exponentially. So in low Earth orbit, the number of spacecraft that are there has grown. And we're getting to the point where it's really a tipping point. If spacecraft go dormant, if they die at the end of their mission and they're not taken out of orbit, they become obstacles that then could be run into. And potentially there could be an event called the Kessler syndrome, where there could be multiple collisions that create fragments in that orbit. And after a while, that entire orbital sphere becomes unusable. So we want to prevent that. And so our concept is to provide a product called a drag sail that's launched on board a satellite or a launch system, could be a payload fairing, could be a launch vehicle upper stage, and allow that space object to deorbit at the end of its mission, aided by this deorbit system, the drag sail. The FCC mandates that any satellite that launches into low Earth orbit needs to deorbit within 5 years of its end of mission. That mandate went into effect in 2022. In fact, there was one company that ran afoul of that rule that was fined a significant amount back in 2023. So the rule actually does have teeth. And so companies are looking for ways to deorbit their satellites and their launch systems at the end of life.
So how does Spinnaker specifically help address the problem of orbital debris?
So most satellites that launch into low Earth orbit, which typically is between 400 kilometers and 2,000 kilometers altitude, most that launch below 500 kilometers are going to re-enter naturally within a reasonable amount of time, within a couple of years or less. But most satellites that are above 550 kilometers need to have some approach for accelerating their deorbit. So they deorbit within that 5-year period that we discussed from the FCC guideline. And so that's where drag sail comes into play. Satellites that have propulsion may use propulsion to deorbit. Those that use low thrust or electric propulsion, they may be able to deorbit themselves. But for satellites that don't have propulsion or that don't want to allocate enough propellant to do that deorbit, which is a very propellant intensive activity, they can benefit from using drag sails. And so what we've developed is a product line of drag sails such that a customer can choose effectively the relevant size of drag sail to get their spacecraft out of orbit within that 5-year period. So our product line is called the Spinnaker product line, which is named after the large sail that yachts and sailboats use when running downwind. And so our smallest class of drag sail, of Spinnaker drag sail, is called Spinnaker Micro. And that's used on CubeSats, which are very small spacecraft that can be anywhere from a few kilograms up to a few tens of kilograms in mass. And the Spinnaker Micro design is such that it actually is integrated internally to the CubeSat structure. And then it deploys from the end face of a CubeSat when it's commanded to do so or when it's timed to do so. And that allows the CubeSat to be able to use a conventional commercial deployer rather than attaching the drag sail external to that CubeSat bus. We also have kind of our standard Spinnaker, which can deorbit spacecraft anywhere from 30 kilograms all the way up to 200 to 300 kilograms. And get them out of orbit within 5 years, all the way up to about 600 kilometers of altitude. And then our largest Spinnaker is Spinnaker Max. And that's used for spacecraft or launch systems up to 900 kilograms of mass and can get them down from high orbit altitudes up to around 650, 700 kilometers and get them down within 5 years.
What kinds of objects can you use drag sails for and at what altitudes?
We can use drag sails for satellites, launch them with the drag sail attached already. It can also be useful for launch vehicle components, launch vehicle payload fairings, upper stages, if the upper stage doesn't want to carry enough propellant to do its own deorbit. We also evaluating concepts for attaching a Spinnaker drag sail to space objects, and these could be uncooperative debris objects, and then we would deploy the sail and have the sail deorbit the object to get it out of orbit. That's considered an active debris removal application. In terms of the orbital altitudes where Spinnaker drag sails are relevant, it's anywhere from above 500 kilometers up to about 800, depending on the mass of the spacecraft, maybe even up to 1,000 kilometers. We can deploy at those altitudes and get the system down within 5 years.
Any takeaways for our followers that you'd like to give us some insight into?
Sure. So Applied Aerospace has been involved in the space industry really since the beginning. That we've been around for 60 years, so truly an Apollo era company, but staying at the forefront of space applications is very important to the company. And so Spinnaker is one demonstration of that. We're looking to lead the industry in terms of keeping low Earth orbit sustainable. A combination of the drag sail leveraging the capability provided by Applied Aerospace in terms of precision manufacturing, the thin film polymers, the booms, deployable booms that are provided by the Huntsville organization. Those all work together seamlessly. We're also leveraging the new manufacturing facility that Applied is investing in the Huntsville area, and that's where the Spinnaker drag sails are going to be fabricated.
David, thank you very much. We wish you every success, and we really look forward to seeing Spinnaker in action.
It was my pleasure. Thank you, Kevin.